it's starting up.
Yes, recording is on.
And you can still see my screen. Is that correct?
Yes.
Yep. Yes,
Okay.
yes.
It's excellent. All right, so there are a couple of people already there. Maria, can you see the Q&A now?
No.
Can anybody else see the Q&A?
I have a special tool where there's F and A, which is German, Fragen and Antworten. So there is some tool with Teams, but I don't know if everybody has it. But nobody's put the message.
I can see Q&A next to chat.
Yeah,
in
that's
my
the same.
phone.
That's the same for me. Q&A's next to chat, and I just tried to post something. Can someone read that? I wrote test for Q&A.
Yeah, it works.
Okay. So Maria, responsible for Q&A, is the only person who
No,
can't see.
I can't see it.
No worries, Maria. Then I will oversee that.
But I don't know if everybody can use this. I don't know if it's easier to use it with the chat function. Because I think probably only the ones who have a full paid Teams account maybe can see it. But either way, okay. We're here to test it. I have also no experience.
Till now, things work out pretty good, I have to say. So Maria, I'll ask the people, all the attendees, to write in the chat, because you can do the chat, and I think that's nice. Will that work for you?
Yes.
Oh, lots of people join.
This is
More
nice.
than 40.
Yeah. Yeah, we have
More than 40.
151 registrations.
Wow.
So I hope there will be many people present.
Yeah. But I registered 3 times. So 141 plus minus 3. I registered 3 times, but I did not receive the response.
Okay.
Maybe later.
We have to work on that, yeah. Maybe it's in your spam folder. That can also happen.
Yeah.
So I have people from India. This is excellent. Shall we start straight or wait one more minute?
You've got 56 people, 57 people.
Okay, so let's wait for another minute and then
Oh,
I'll start.
we're going to have 60. Yeah.
You're at 60 now.
This is a good point where we can start. So good morning, good afternoon, and good evening, everyone all around the world, and a warm welcome to today's IEA Bioenergy Task 37 webinar, Manure to Biogas. We call that Global Lessons on Challenges in Unlocking Farm-Based Potential. My name is Hayo Negele from IEA Bioenergy Task 37 Switzerland, and I will guide you through this webinar today. My co-host is Maria Wellisch. You can also see her on the screen. She's responsible for the chat. So if you have any questions, do not hesitate to ask her. She's trying to answer all the questions. We are very pleased to see such a strong interest in the topic. We have 150 registered people, more than 60 now with us in the webinar from all around the world. And I think this reflects very well how timely and relevant the role of manure-based biogas is all around the world in achieving both climate and circular economy goals. Today, I'm really happy that you can hear from leading experts from all around the world, which will share insights from different regions, highlighting successful strategies or remaining challenges in scaling up biogas production from agricultural sources. Before we begin, just a quick dive into technical notes. I wanted to ask to keep your microphones muted during the presentation to avoid any background noise. The chat is open for discussion, so feel free to post questions here. Maria will answer them if possible, or we keep them for later for the Q&A session at the end. Just a remark, the webinar is recorded. All presentations and the recordings will be available after the webinar on the Task 37 website. We are going to show you where to find that in the end of the webinar. That's from my side. With that, let's dive in. I'm happy to introduce our first speaker. That is Bernhard Drosk. He's leader of Task 37 of IEA Bioenergy. He's from the Institute BEST in Austria. He has been with the task for a very long time, and he's now giving a short introduction in the role of the IEA Bioenergy Task 37, who we are, what we do. Bernhard, the floor is yours.
Thank you, Hayo. Very kind for you to moderate today together with Maria this webinar. I don't want to steal a lot your time, just a few minutes to give you an idea what is IEA Bioenergy Task 37. We are a technology collaboration program, and we work within the framework of the International Energy Agency. Our mission is to increase knowledge and understanding of bioenergy systems, especially with a focus on environmentally sound, socially acceptable, and cost competitive bioenergy systems. So this is what we stand for, and we want to be independent collaborative body which focuses on clear and verified information. So we try to exchange this knowledge throughout different nations. Currently, we have 17 participating countries in our 3 years work program. I don't want to go too much into detail. Strong focus on Europe, but also India, Canada, Brazil, Australia, so also some countries all over the world, more or less. What is international knowledge exchange about? Here you can see one of our first meetings. We had this triennium actually in Norway. We had a business meeting and we visited a biogas plant there March of this year. Just to give you an idea, why is this webinar on the topic of Manure? So we had our topics in the years 2022 and 2024. We had a strong topic about assessment of co-benefits of biogas beyond energy in circular economy systems, and that's what I highlighted, a detailed assessment of an optimized utilization of manure. Here we exchanged views, and this ended in a report we published and the webinar today. Another focus is the decarbonization of food and beverage industry, energy and transport fuels from renewable gases, and how to deal with and reduce methane slip in biogas systems and landfills. We also have country report summaries, case stories, inter-task work, and newsletter. I don't want to focus so much on this. To give you a glimpse a bit about what is upcoming, so in the next 3 years, we will have the topics sustainability. This is a topic which continues with the co-benefits of biogas, as this is a vast topic. We will talk about field application of digestate, monitoring of microbial cultures in biogas plants, and also economics and greenhouse gas marginal abatement costs. Other topics are home biogas systems and biogas systems and synergies with e-fuel for production. So this is the more topics we have, and we also will have again case stories, country report, and inter-task cooperation and the newsletter. How can you interact with Task 37? You can visit our homepage. Very long tradition we have also for a newsletter from Arthur Wellinger, so you can register where you can get regular updates, and you can also have a look to see what are the webinars and the workshops. And don't forget our publications. You can go to download technical reports, country report summaries, and also our case stories. So that's it. Very short introduction, just to give you an idea about IEA Bioenergy Task 37. So thanks a lot.
Thank you very much, Bernhard, for this kind of introduction into Task 37. There's also an account for Task 37 on LinkedIn. If you check for Task 37 and Biogas, you'll find it on LinkedIn as well. And via LinkedIn, you get all the information on short notice what we do. So try to register there, then you get all the information. Bernadette, can I ask you to share your presentation? Because she's our next speaker. Bernadette McCabe, professor at University of Southern Queensland, Australia. She's director at the Centre for Agricultural Engineering. She's a long-standing member of Task 37 and does a lot of research in the field of biomass and bioenergy in Australia. She has a long-standing experience within the agricultural sector. And today she's giving us a talk on manure-based biogas systems and a comparison of 7 countries, one of the reports we have done. The floor is yours, Bernadette. I'm looking forward to hear your presentation.
Thank you so much, Hale. Just a bit of a preface to say that this report was actually done in the triennium previous to the last one, even so published in 2021. It was, I guess, the originator of the series on doing a collective of understanding various countries' approaches to manure utilisation for biogas. So to begin, I'd just like to acknowledge the authors of this report, because we've had 7 countries participating, namely Austria, Australia, Canada, Germany, Ireland, Norway, and UK. Our authors are all representatives of those countries. So Jan Leberto from Germany, Richard O'Shea from Ireland, Maria Wellish from Canada, Carrie-Anne Ling from Norway, Gunther Wachmann from Austria, myself, and Peter Harris from Australia, Claire Lucas from the UK, Peanut Cornett from Germany, and Jerry Murphy from Ireland. And also to acknowledge the very brilliant editing of Jerry, our former task leader, who did a lot of editing on those earlier reports in that previous trienniums. So The report, as Bernard has alluded to, is available on the website. And so whilst I only have really 15 minutes to give you an overview of a fairly dense report, I do encourage you to go online to have a look at a lot more detail. And all of the links there in the presentation, which you'll have access to later on. So to begin with an introduction, we've prefaced this whole concept of utilising manure as basically the perfect example of a circular economy, a very sustainable one. But we pointed out there's various, hurdles that countries have to overcome in order to get full utilisation, and that's essentially what this my talk's going to present. So as we know, manure management does contribute significantly, sorry for that typo there, to greenhouse gas emissions from agriculture, both in the form of methane and ammonia. And it can reduce emissions by using anaerobic digestion, while also at the same time producing an energy source in the form of biogas to replace fossil fuels, as well as digestate, which can be used as a form of organic biofertilizer to replace fossil fertilizers. And if we look at the diagram there to the side, this is a concept diagram taken from Italian biogas done right concept. And it shows that that whole circular economy in action, from expanding sustainable biogas production to some other possible impacts. And we have done other reports which I refer to there. Two previous reports I want to make mention, which places the circular economy or the benefits of using manure, comes from TR's technical report, methane emissions from biogas plants. And this was an important one to highlight the positive impact of slurry digestion in terms of saved fugitive methane emissions from open storage of manure and slurry. And so have a look at that, because it's also important to show how biogas plants are monitored for fugitive emissions as well. That was led by Jan Libertrop from Germany. And then there's another one on integration of anaerobic digestion within the circular economy, but particularly in agriculture. So if you want to learn a bit more around how other countries are doing that as well, I'd encourage you to have a look at the importance that AD is in terms of circular economy. So moving on to then, what are the key concepts of what makes for a successful application of a biogas system? If we were to distill a lot of the learnings that come from the countries that we've highlighted, it basically boils down to three key aspects. That is the availability of manure, whether it's in sufficient quantities, and also the characteristics of the manure. So we'll see that not all manures are the same in terms of their ability to produce methane. And when you put all those together, that will then go on to what will constitute a profitable biogas facility. So if we look at the first, 3 points there about the manure and whether it's quality and quantity, but also its characteristics, we can kind of look at that in terms of the actual type of animal husbandry in various regions, whether it's, Northern Hemisphere, Southern Hemisphere, all of which has different climatic conditions as well. So that amount, that accessibility and the characteristics are dependent on the type of animal, which you'll see because we've put a lot of numbers behind the various countries and their herds. The method of housing, whether they're on pasture-based or whether they're housed. The feeding regime actually also has an impact on the amount of biogas, and also the purpose of the animal, whether it's just purely for breeding or whether it's actually for production, i.e. for meat, milk, bread, eggs, or production as well. And importantly, the herd size. So you'll see that some countries, due to small herds, means that the economics doesn't stack up. And then we go to the actual viability side, that is that profitability. And we've seen it in terms of the supply of manure, that is, if it's year round, and that's particularly so for the more, I guess, countries in the Northern Hemisphere. In Australia, it's less so because of that inability to actually have access to due to different seasons. And then, of course, the end market for energy and biofertilizers. So those offtake markets are extremely important as well. So I'm conscious of the time and I've got 7 countries to go through. So I just wanted to pick out a few important points from every country, which I could distill. And in each of the countries are highlighted in the report, it has the actual amount. Now, also remember, this was a 2021 report, so the information that's contained in these slides is like a line in the sand. Things have changed, 4 or 5 years on. And so some of these, particularly in terms of the incentives and the direction for which the country is going forward, may have changed. And also, I guess maybe the amount in terms of tonnage may not have changed as much, but certainly political landscapes do. But what we've given in every country is the actual tonnage of the biogas. And here in Germany, basically they've got 53.3 million tonnes, which approximates to around 4 terawatts of electricity-based manure. Now, as you know, Germany was very much an early adopter of agricultural biogas plants and is the country that leads the way in that. But if we look at recent changes, it means that the policy settings have changed, so that even though Germany has large amounts of manure for biogas production, only 2/3 of the manure, are not in use. So in the long term, what the government has declared that an ambition to reduce emissions from manure management and biogas is seen as a primary first option to actually increase that. So whilst there was obviously there was changes to the EEG back in 2014, which was probably represents one of the biggest changes in that in terms of those that financial support. We are looking at, and this will be what I'm seeing as a recurring theme for countries in terms of where to what's that lever to pull. And I think emissions reduction seems to be coming out in most countries. If we turn to Australia, again, I've presented a map. And Australia, look, we are 2/3 arid. So right in the centre there, not much happens. We are all on the fringe of the east coast or a little bit on the west coast as well. And that is primarily, the population is hugging the coastline, but also inland and a bit beyond is on the coast is where all farming takes place. And just like in most countries, the relevant livestock sectors do include cattle in both feedlots, dairies, pigs, and poultry for both meat and eggs. And again, we've just got a bit of a breakdown to the herd sizes. In Australia, we produce a lot of cattle. We've got more cattle than we have people. And then followed by the poultry sector. So there's also numbers in terms of the actual, methane potential of each of those. And if you can see that whilst we have a lot of feedlots, our management practices of that manure means that it is stockpiled and it's composted, and because of the non-frequency of harvesting, none of the we do not have biogas or utilization of beef feedlot manure using to be biogas currently, unless that manure management changes. So for a little bit more understanding of those practices, I refer you to a journal article that has been authored by my colleagues, Stephen Tate, Peter Harris, and myself, which is quite a comprehensive overview of what's happening in that area, but also a report on the actual feasibility of feedlot manure. But in terms of, just like Germany, biogas energy potential is quite substantial in Australia, but the idea of manure is in its infancy in Australia. with increasing adoption, particularly in the pork sector. And I just highlight the success story that was published in 2018, which looks at the pork sector in particular. Challenges in Australia include lack of financial viability, poor policies supporting purchase agreements, complex project development and operation conditions, the inconsistent regulations that are placed on various states also mean that digestate land application is difficult, and also the fact that it's a very big country, the access to infrastructure in terms of transport is a big one. So moving on to Austria, again, we've got a total amount that's been reported in this document at 31.6 million tonne per fresh matter. With regard to the actual size of the enterprises, Austria has been one to be affected in that small family farms still account for a large number of farms, but their number is constantly decreasing while the area farmed and animals kept per farm are increasing. In 2018, the share of manure within total feedstock biogas facilities was around up to nearly 6%. In Austria, the biogas industry has been challenged with low feed-in tariffs. There is no national strategy, and my learned colleagues on the line can be able to update you more in terms of what the current state of affairs is. In terms of those smaller scale farms, it's, you know, in comparison to the countries that we well know for larger size farms like Germany, France, and the Netherlands. With the biggest challenge in Austria for farmers in some regions with the high animal numbers is the reduction of manure caps and reduction of the period where manure may be applied to land. In Norway, we've got some numbers there in terms of the actual size of farms and numbers, and just to point that we have a theoretical amount and then also a realistic potential, which is estimated to be modelled up to 796 gigawatts in 2030. One of Norway's biggest drivers, as I mentioned previously, which we see as a common theme, is that their ag sector is committed to reducing their emissions, and you'll see that they have a plan right out to 2030. And that biogas production from manure has been identified as the most important measure to achieve this commitment. An important barrier is lack of economic profitability of farm-scale biogas, again, due to small volumes of manure and the insufficient income to cover the investment and maintenance costs. Now, though, despite the political ambitions to increase that share of manure, as you can see, that's been happening in that diagram there up to 2017, there's still only 1% of the total amount presently treated by AD. And the support schemes per tonne of manure used for biogas production has been a driver and can be expected to increase when there was a change of status from a pilot to a permanent scheme back in 2020. And of course, again, that situation may have changed after 5 years post-report. Canada, you know, we have Maria online, and you'll hear more from the report that Saya will be talking about. But basically, you've got that amount of tonnage there. The most manure is land applied as fertiliser to ag soils, with a small percentage undergoing composting before application, which is a similar case to Australia. And that 1% of total manure is converted into biogas and digestate. Now, I've got a lot of information there, which is talking about the theoretical potential, and also when Digest AD began, which was 2000s, which was supported by FIT programs that were established in several provinces to increase the renewable electricity. And I'd like to point out again that reducing greenhouse gas emissions from manure management is being mentioned more frequently in the area. And I think it's, you know, one of those national plans that Canada will undertake as well. In terms of just going forward with those GHG emissions reductions, it's a difficult one until we actually see a market appearing, and because they're emerging in terms of the carbon credits, we're just not sure what revenue that might be in terms of sale credits. In Ireland, like Australia, has a very nascent biogas industry with 12 AD plants which digest manure. In Australia, the pork sector would have upwards of about 20 systems and represents the most viable one in Australia. Now, there was some, in that report, there's some great theoretical numbers that were put forward in terms of actually what that might represent. But they do point out that the use of animal manure with other additional feedstock through co-digestion is important to produce higher methane yields and therefore increase the financial viability of the plants. And in this text here, it does refer to some planned projects such as Graze, which aims to use biomethane from a number of farm-based AD plants using grass silage and food waste. And that therefore demonstrates that Ireland is looking at more innovative ways to utilising manure. Now, turning to the UK, I'd say that UK has done some interesting work on small scale biogas plants using manure, and there is some other reports that refer to that, earlier reports that are on the task website, and they indicate that there's potential for 113 million tonnes, with a significant portion likely being in that, especially with high proportion of bedding material. So again, they look at the different types of ways that the animals are housed as well. The main obstacles in the UK, no different to other countries, has been government's lack of continuous policy and the stop-start nature of the support mechanisms. Support for electricity in the UK has ceased for farmers, and farmers must negotiate with power purchase to secure wholesale prices. So there are some other important support mechanisms which look at biomethane production in the new green gas support scheme and with the closure of the renewable heat. So I've just then distilled those main points in terms of the conclusion for manure utilisation, but it basically goes back to the introduction. So I'm conscious of time, so I will just thank everybody for your attention, and I look forward to discussing more in the Q&A.
Thank you very much, Bernadette, for keeping the time and for this excellent presentation with a lot of information, as you have seen. So more information is found on the report that Maria posted in the chat. So if you want to go more into detail, follow that. Thank you very much again, Bernadette. So we're moving on to the third speaker of the day. It's Saija Rasi from the Natural Resources Institute in Finland. She's a principal scientist there and has a lot of experience in the field of biomass, biogas, and bio-based products, and has been also a long-standing member of the IEA Bioenergy Task 37. Today, she's talking about the potential for manure-based AD systems, motivations, barriers, and approaches in 6 countries. Saija, we're looking forward for your presentation. The floor is yours.
Thank you for the kind introduction, and hi everybody. Yes, this is like a follow-up report from the previous one, so what was just presented, and I just to highlight that this presentation was made with Maria Verish and myself, and from this sorry. So this technical report was just published this year, March. And here you can see the authors and the country participations. So Canada, China, Finland, France, Norway, and UK participated on this report. And so 3 new countries compared to the previous one. And also from the other countries, there's a little bit more updated info from compared to the previous one. But in general, the report presents the country's motivation to adapt of manure-based AD, some policy content, barriers, and some solutions, how different countries see this manure-based AD. Here's just a rough comparison from these 6 countries. Don't look so detailed on the figures because there's data from different years from different countries, so not exact numbers, but you can see that the China is in a total different level from when you see the number of AD plants, and also France has a lot of AD plants treating manure. And in generally, exception of France, the countries have quite small amounts of manure treated in AD, and also different scales. That quite many of the countries have small scale AD plants and CHP production, while in China there's also large scale plants, and also in France more larger scale. Then I just have a short view on Finland and France, because they were not presented in the previous one, and also China is coming up later today. So from Finland point of view, the number of plants have increased recently, the AD plants in general, and this is mainly due to the increase in farm scale biogas plants. So the amount of energy produced has not increased that much, but the number of plants are. And now we are expecting quite a huge increase on also for the energy production, because there are now 8 large plants under planning, and they will digest mainly manure. So we're expecting the double the energy production with AD. And also there are plans for 11 farm scale and 10 farm cooperative plants. So a lot is happening now in Finland, and this is some general targets are that we should have a carbon neutrality by 2035, which is quite tough, but it's still the target. And also there's a target to be a model country for the nutrient recycling. And one of the drivers is, you can see the picture in the right hand side, that which shows the manure phosphorus per field area in Finland. And you can see that there's quite a lot of manure and manure phosphorus in by the sea. So there's a high interest to protect the Baltic Sea from these nutrients. Of course, there's a lot of other affecting things also for the Baltic Sea, but this is one of the issues to recycle the manure and fertilizers in it. In France, manure is mostly concentrated in the western part of the France, but the manure represents over half of the total feedstock of entering the AD plants. So it's a good country to look some inspiration how to utilize manure in AD plants. There are some farmers that are joining together to build collectives and also accept different types of feedstocks, and they still have ways and expectations to increase the manure utilization, as there's some financial incentives that favor manure as a feedstock, and also public-private partnerships and ongoing technical improvements. But then going back to the kind of a bigger view, all the 6 countries in the represented in the report have shared the same motivations behind manure utilization. So there's we want to increase the renewable energy production and reduce the emissions, have a sustainable livestock production, and prevent some water and air pollution. But also there's a driver to diversify the farm income and also increase the farms and agriculture's energy self-sufficiency. And of course, there's a broader societal motivation just to, in general, increase renewable energy production and management of organic wastes. There's high feedstock potential in most of the countries, but not so much adaptation. So there's specific challenges for all the countries that there's the low methane potential of manure and a lot of small scale farms. The small farms that that there's this kind of cost issues with the smaller plants as well. The drivers has changed from the renewable energy into the emission reduction, and also the biomethane is preferred as an end use more and more, which is favoring also the larger plants, which might be challenging for small farms. And still there's this problem with the high investments. About the policies, in all countries there is a requirement of the public support, and then there's a different ways that is achieved in different countries. For example, in China there's a recommending for manure treatment. In Finland and France and Norway there's investment grants and operating incentives, and there's also like specific targets for manure-based AD, both for biomethane and electricity. In Canada and UK, there's premiums for biomethane, and in Finland, there's also a grant for phosphorus recovery from digestate. And there's a lot of hopes and dreams for the carbon markets that could also be some solution in future. For the feedstock supply, due to this small scale farms and low methane potential, the co-digestion with other substrates has been done in all of the countries. It a little bit varies the co-substrate, if it's food waste or intermediate crops, but in all countries have seen the same solution, and also this centralized AD plans that kind of helps with the economics, which can be owned and operated by cooperatives or third parties. There's a project approval and acceptance. So in many times there might be complexities and long time for approval the process. In UK, the manure is still classified as a waste, and in Canada, there are some variation between the provinces, and also the increase in project costs and even loss of financing opportunities is some kind of barrier. There's always this acceptance for new projects. With larger projects, there's usually more hesitating for accepting the projects, and so there's a need for the good design and operation of existing AD plants, and a lot of dissemination and building the relationships with the surrounding community that is needed. And also what was common for all the countries, that some challenges with the distances of the farms. from energy users and other farms, and location and capacity of the natural gas pipelines. All of the countries have noticed that and notified that the feedstock clusters and co-digestion is a solution, and also especially in Finland and Norway, there's also this compression and or liquefaction of biomethane that is trucked to users. In France, there's a reverse flow recompression stations in local distribution lines, and all the countries are trying to optimize the feedstock collection equipment and logistics, including the digestate delivery. With some technology, design, and equipment and operation point of view, there's some challenges. Although the equipments are mostly mature, there might be some operational issues, and there's still need to improve the market and products for the digestate and also CO2. Some of the different solutions from different countries that can see the import expertise and equipment from other countries. There's a quite good government supported R&D in Finland, Norway, France, and China. Also in China, there's regional system demonstration projects. UK and France has tried to develop the technologies for small-scale systems, and in Norway, there's a lot of educational programs and this public education center, and also the use of biogenic CO2 is strong and going forward with the CO2 utilization. There's still more opportunities exist to expand the manure-based AD. In most of the countries has substantial feedstock potential, and all of the countries in this report has increased the production, and mostly are going into larger and centralized production, and also the production for biomethane. There's still a need for technology and policy solutions to capture the small-scale opportunities, and there's always need for the knowledge sharing, and which hopefully we are also doing here today. Okay, thank you from my side. Unfortunately, I can't stay for the rest of the happening, but I can try to still follow the chat. Thank you.
Thank you very much, Saya, for your presentation and for this deep insight in different countries. That was very insightful. I enjoyed that. Thank you very much. So I've seen there are a couple of questions in Q&A. I'll keep that for the discussions we have later. So be patient. I'll address them in the end. We're now moving to our next speaker, Torben Grell. He's a research associate at University of Western Australia. In Australia, he has just recently finished his PhD at University of Southern Queensland, and he's focused also on different strategies for manure treatment in Australia. And we'll love to hear his experience of his work there. So his presentation will be about the Australian dairy industry, the impact of production systems for resource recovery and technology selection. Torben, your presentation is up. The floor is yours. You're still muted. You should unmute.
Yes, perfect. Thank you so much for the warm introduction, and that was spot on, so I can directly start. As you already mentioned, I focus predominantly on the Australian dairy industry, and my presentation is structured as followed. So I talk about the manure management in the Australian dairy sector, and we do find 3 different production systems which do have an influence on the methane potential. And we also found out that different systems use different cleaning strategies, which do have an influence on the effluent characteristics, which are then highly relevant for the technology selection, such as solid liquid separation or AD technologies. I will conclude my presentation with methane emission reduction strategies and energy recovery potentials. So as I have mentioned, we have 3 different production systems. On the left side here, you see complete pasture-based system. That means that the cows are predominantly out on the paddocks and eating the pasture from there. So they're almost purely grass feed. We clusterize them. Usually we say over 80% is grass feed. Meanwhile, we also have a partial mixed ratio feeding, which is they literally have feed pad next to the dairy shed. So before the cattle herd goes into the dairies, they get a little bit of supplement feed on the feed pads. So, and the other one, TMR system, all the European are familiar with it, that is completely housed. So the cattle don't go outside and they get the feed delivered to their place. As you can imagine, manure collection is only possible on concreted surfaces. So as in PB systems, the housing is low and we only have dairy shed, the milking operation, that's where we can capture the manure. Meanwhile, in PMR system, we can capture the manure from the feed pads and the milking area. And in the TMR systems, we can capture them completely. So the higher the housing intensification, the higher the manure collection and the higher the recovery potential. When we then investigate the individual methane yields of the different production systems, we actually found something really interesting. We did found that PB systems produce a methane yield of 160 liters of methane per kilogram VS, while we found out that the TMR systems in Australia produce around 200. So that is highly relevant also for Australia because the IPCC recommend the country-specific methane emissions for national greenhouse gas accounting. And when they are not there, they calculated with 240. And obviously we haven't found that. What was a really interesting outcome as well is that we investigated solid liquid separations, and we actually found that effluent releases 90% of the methane potential in around 15 days, while the liquid fraction of this effluent was released way quicker. So on an average at 8 days when the biggest solid particles are removed. Meanwhile, the solid fraction needs about over 20 days to release 90% of the methane. So that have actually really important implementations for the emission reduction strategies. So the next one, we come to the impact of the cleaning strategy, where we found that the most dilute effluent occurs when we float wash, followed by hose wash, and when we scrape the manure, as we do, or as you do often in Europe, that's the most concentrated one. So it actually, as you can see here, in pasture-based system, we usually float or hose wash the milking area. Meanwhile, on the PMR system, the feed pad can also be scraped. So it's highly difficult. The PMR systems are hybrid systems, so it's always they can be more towards a pasture-based system or more to the TMR system, depends a little bit on the management. However, the dilute effluent we generate by float and hose wash are generally 0.5 to 3%, while the slurry we collect from scraping are usually 8 to 12% total solids concentration. As that has an impact on the solid liquid separation, I prepared a table out of my PhD, and I put different parameters on the left, listed a couple of suitable separation technologies at the top, and compared them in terms of complexity, TS influent, and at the bottom you find potential use in the different system where it's suitable. I'm not going to talk more about the table because 15 minutes is short. And we advance to the solid liquid separation. A brief overview: solid liquid separation, we collect the effluent, send it through a filter, then we generate a solid fraction and the liquid fraction. The solid fraction can then be composted because the C/N ratio is beneficial, and or as well digestated because the TS is highly up concentrated. As you can see, from 1 to 3%, we can reach up to 25% with some technologies. And the TS to VS ratio is from 75 to 90%. So it actually really makes it interesting to might even transport solids from small dairies in case there's a solid liquid separation in place to centralized AD facilities. However, when we look at the filtrate and the storage of the filtrate, we do know that Manure storage release fugitive methane emissions, but by reducing volatile solids from the effluent in the filtrate, we can actually reduce the volatile solids concentration of 25 to 35%. And when we use flocculant, like a chemical enhanced separation approach, we can increase that to 80 to 90%. And of course, this has a massive impact on emission occurring from effluent storage. I would like to show a brief example of my experiment where I did the
to nutrients. That's 9 years ago. That's 2016. Since then, the government released different type of policies or instructions to support this development. Until 2 years ago, 2023, there's the other drying factor come, that is the methane reduction and control action plan. That's Chinese Ministry of Environmental Protection released that action plan, and in that action plan, follow that. So next year, this last year, 2024, the animal production and paddy rice, the two parts in the agricultural sector, are the top priority that the government would like to monitor the methane emission and try to reduce also the methane emission. So the biogas plant becomes more and more important. In China, there is a long history. 2,000 years ago, we had the people to use the biogas in a temple, and then that's about 100 years ago. There was an industrial company, a commercial company, to promote the biogas technology small scale until now. So here is a biogas development after the new China was set up. So the left side is the household biogas reactors. Can see the data dropped because nowadays there is not enough feedstock for the household biogas reactor because the animal production becomes more and more intensive. And on the right is we call it biogas engineering or biogas plants. The medium and large scale biogas plants, the number increased. But recently, from 2 years ago, the biogas plants number declined a little because in the past it's too many, and some biogas plants, the quality is not very good. So was not very good because that was built 10 years ago or 20 years ago. So those kind of biogas plants just disappear. So the number, but the increase, the number in the new biogas plants in China, the increase is less than the decrease. So that's the reason that the total number reduced. But 2 years ago, the Chinese Society of Biogas, China Biogas Society, we organized an overall assessment. And we found the biogas potential from the bio-waste in the agricultural sector, or from the whole country. This is pretty high. That's pretty high. It's much higher than if we convert all the bio-waste into the biogas, then we can replace 100% or even more, 100% of the natural gas imported. So this is a very big potential. If we look just to focus on the animal manure, you can see if we put all the manure, almost all the manure into the biogas plant, we produce again a very huge amount of biogas. Not only so in China, we have a good understanding about the nutrients in the biogas plant, in the biogas digested, and also from the biogas fermentation process, there will be the plant hormones and some amino acids produced from the biogas fermentation. So those are the benefits of the biogas plant. And lastly, that's the methane emission reduction contribution or greenhouse gas emission reduction. So we produce the energy, we replace the natural gas, we produce the fertilizer, we replace the chemical fertilizer, and we put the residues into the soil, possibly to increase the soil carbon storage, and we avoid the emission, we protect the environment, we avoid the emission. So in total, we contribute to the greenhouse gas emission reduction. Here's a calculation of the dairy sector. We calculate one dairy pool in the 1 year. So from the feed production to the transportation, to the manure transportation, manure treatment, to the energy, fertilizer, carbon, soil carbon, all the things from the field back to the field again later. So the whole cycle, you can see here is on the very right. This is the biogas. This is biogas with the digested covered, and on the left is the open lagoon. To put manure in the open lagoon, just put aside. So if we compare the two extremes, you can find that 70% of greenhouse gas emission reduction, even more than 70%, can be created by the biogas plant. So because of that, the large biogas plants, they are more and more big, very huge biogas plants in China, very successful. One, I give you 3 or 4 examples. One is a dairy, is a modern farming. That's a huge, the second largest dairy company in China. They have about 60 dairy farms. And the largest single dairy farm is 40,000, 30 to 40,000 dairy cows. The feature of them is that they build biogas plant for each dairy farm and treat the manure. After the fermentation, they do the solid liquid separation, and the solids is dried, and then to return to be the bedding. And the biogas is used for the electricity production and for the steam production, so that they can have more than 25% energy they can produce from the manure. And they invited an international company to come to make an evaluation of the greenhouse gas emission reduction benefit. And they found, for example, for a 10,000 dairies farm, they invest about 40 million yuan for the biogas facilities, and they can earn about 5 million yuan per year. So their investment return is about 11%. The second example is Huijun. This is a biogas design and construction and management and running company. This is a very comprehensive company. They have the technology of the dry anaerobic fermentation or high solid anaerobic fermentation, or CSTR, very common, and USB, that's for the very diluted manure. And they have 2 examples here for I want to share with you this. So because the dairy manure is very easy, pig manure is very easy, but poultry manure is very difficult. And Huijun company, they have the technology to build the huge poultry manure biogas plant and put into drying successfully. So for this case, they invest about 65 million yuan, and their investment return is about 10%. And the second dairy, the poultry manure biogas is we call that Shunwo. That's also a very big biogas plant, but they upgrade the biogas into the biomethane, and they inject the biomethane, they sell the biomethane for the neighbor industry use, so that they can make a better money. And the number three, very big biogas company that's supported by the Asian Bank. That's Asian Bank supported, and the investment is much higher, but the feedstock feedstock is a little different from the manure, but it's a manure together with the crop residue. And this very huge biogas plant is in China we have a county level. So one county there will be such kind of huge biogas plant. So they treat all the crop residue and together with some manure. So the manure to be mixed with crop residue, so that to reduce what this the advantage is that to reduce the manure's the water, the liquid, because if we mix the liquid manure together with the crop residue, we can reduce the liquid discharge, so that to avoid the liquid treatment, further treatment difficulties. And this is here is for this kind of this is the dry so-called dry fermentation, and you can see here this is the fermenter. It's very different from the ordinary fermenter. And after the fermenting, so here's the upgrading, and after the fermentation, they put the pretty small amount of liquid in the tank, and they have here is a composting area, so that to for the solid digested, they put here again for the composting. They have a very clear calculation, and so I want to say to share with you that the 2 points, that's total internal rate of returns of around 9%, and the payback is about 9 to 10 years. And the last one, very interesting. It's this for the whole world, for the biogas plant. The Wanhao Energy company, they received ISCC double credit. So when they have the accreditation on the liquid natural gas, biological liquid natural gas, and also the liquid carbon dioxide. So they have the two accreditation certificate. And now they receive again, like the Shangshui, the previous biogas plant. Here is also a very huge one to provide the service to treat almost all the crop residue and manure surrounding this biogas plant, so that and they upgrade the biogas into the biomethane, and then to put into the liquid phase. And then they have the here there should be a tank truck every day to accept the liquid LNG to transport about 200 kilometers to the ship. Okay, the last one is the small biogas. The huge one, this quite interesting, but it cannot solve the small animal farms manure problem. So here is for the small animal farm, they don't have enough big money. They cannot have the big money loan from the bank. So they have to use their own money to build the very cheap, the soft dome reactor or the concrete reactor. So the investment is very cheap, and it can run for about 10 years. Okay, this is the cases, and here's my laboratory. And every year we have a Great Cycle meeting, and you are all invited to join our Great Cycle meeting in October this year. And here I want to say the call for cooperation. So the biogas development, biogas plants promotion cannot yeah, we can do that very well inside the country. But if we have an international cooperation, that we will make things easy, much easier. So I suggest we cooperate between the countries or internationally. We can have the database, and we can have the manure treatment and methane emission accounting methodology, and we can have an accreditation of biogas plants. Here, I quoted from the European publication. I like that. And we can develop the biogas standards. And okay, welcome to join the Great Cycle meeting. So this is my suggestion for cooperation. Okay, Hayo, that's my presentation. It is the time is limited, so I give you my slides so you can share with the people who like that.
This is excellent, Randy. Thank you very much for your presentation and showing us the scale of manure treatment via anaerobic digestion in China, which is really impressive. And I'm glad we had a final presentation showing the big scale of what can be done and also the small scale. So thanks again, Randy, for this insightful presentation. As said before, all presentations will be shared. Now, as time is limited, we are heading right into Q&A. And there are a couple of questions, and I start just with the first one. There has been a question from Trevor. He stated that many work has been done on adding biochar into manure management and methane production. He's seeing a lot of reports. Does that increase biogas production? Is one of the experts from IEA able to answer these questions on the pros and cons of adding biochar into manure or manure and digestion? Are there any opinions about it? I'm not quite sure if anybody can answer that. I just can answer for myself for Switzerland. There has been done many research on adding biochar to manure and also using it for a field application and fertilizing. We do not see any different effects or surplus positive effects if biochar is added before or after digestion to slurry. We see a lot of development in this sector. A lot of research is done, and the reports or the research we have done on adding biochar did not show an increase in biogas production. But let's ask the other speakers. Bernadette, do you have any work done in Australia about adding biochar?
No, we haven't done any work that I'm aware of, but certainly not, at scale. If that's the question. I would say that there is no reports of plants that are adding that. Yes, there are. There's literature to say that there is an improvement, but Torben, have you come across any other? I mean, there's certainly, in terms of our biogas sector, there hasn't been any innovation like that in terms of scale. But
okay, excellent.
The most we come across biochar in application is actually mixing it with digestate to then reapply into the soil. That is where we see. So right now, thinking about it, biochar is stabilized carbon. We actually, high hydraulic retention time, but I don't know what are the effects in the AD process, as maybe it gives the microbes a better host, but that's right now just guessing.
Yes,
I just know that it's
okay. Yes, in China there are several researches on the biochar adding into the biogas process. The biochar has at least two functions. One is to stabilize the process, and two is to act as an electrons transfer agent. So in appropriate amount of biochar adding in the biogas plant will increase the anaerobic process And some reports say we also increase the biogas potential, but I think it will increase the efficiency so that I'm not very sure can increase the potential, but it will increase the efficiency. And later, when the biochar flowing outside and return to the soil, that is something like a carbon storage. The biochar can be sustaining for several dozen of years or to 100 years.
Okay, thank you, Randy, for giving us more information about that. All the questions we also take with us, and we also can address them during our next meetings, and then see if there are a lot of questions about a certain topic to address them in our work we do within Task 37. There was another interesting question, very often risen, I would say. What are the main technical limits in converting raw manure to high-quality biogas, and how can new technologies overcome them? Bernhard, what would you answer? You're still muted.
Did you mean me? Sorry, Haya?
Yes, I wanted to
Okay.
ask Bernhard, what are the main technical limits in converting raw manure to high quality biogas, and how can new technologies overcome them?
Well, first of all, I would suggest that the organic matter content is very low. So this is definitely a barrier for the implementation of the technology. As we have already seen in different presentations, interesting would be concepts for small scale plants to realize to make profitable plants. This would be suggested from my side.
Okay, excellent. Yeah, there's a lot of work going on also in pretreatment methods for biogas, but it's always a question of money. That's what you've seen throughout the presentations. As ODM is low, energy is not so high, and it's a question of price in the end. There's a question also from Michael Oertig, and he asked, in terms of centralized plants, is there any data available on the maximum distance that manure can be transported via road in terms of energy balance and CO2 emissions? That's a very good question. Who can answer that? Anna, do you have any knowledge about road transportation? We have experts within the Task 37 who's done a lot of research on that, but within the reports that been addressed, maybe Bernadette can also answer that question. Road transportation and distances, is that covered? You're still muted?
Maybe I could just.
Yeah, I'll hand that one over to you, Maria.
Yes, it's not covered in the reports, but our colleagues, particularly from the Nordic countries, from Finland, Norway, and Sweden, would be the people to direct the question to, who are carrying out that type of virtual pipeline work.
Yeah. So yeah, that's a very good remark. All our experts from the northern countries, they are really much more into transportation, and they will have informations about that as well. Yeah, but we take the question with us. Then there's another question about the price of animal manure. May I know if the animal manure is available free of cost in the studied countries? Also, is there a mechanism to decide the procurement of price in animal manure from farmers based on certain specific parameters? Maria.
So I would say in all countries, as in those two reports mentioned, the manure they didn't receive a fee for using. There was no cost to the manure, right?
Yep, excellent.
So I move on to that.
Yes, Bernadette.
So for an Australian perspective, it's utilisation on farm, and any of the energy generated from the AD is utilised at the term we use behind the meter, because feed-in tariff is very low. So it doesn't make any sense for electricity to go back in the grid. So it's about the avoided costs and reduction in energy costs by using it on the farm.
Okay. Yeah, excellent. So there's a question that might be one to Torben. It asking about the gas yield in norm cubic liters per ton of ODM in SLS slurry. And as operation days increase, how to decide if we need to completely replace the slurry with fresh cattle manure. So is there data available for the biogas yield in terms of ODM, Torben? You're also muted.
Sorry. I have reported on volatile solids, and yeah, there's a broad terminology between dry matter, volatile solids. Is it the same? Isn't it not? Yeah, it's 200 liters methane per kilogram VS. And VS are the volatile solids which get volatilized at 500 degrees. So I do think that dry matter is the same, or do you refer by dry matter to TS? Because that's also sometimes which some people, when I go in agriculture, a lot of people talk about dry matter, then you go in the details. Sometimes it's dry matter without water, which is TS. But other people also refer to dry matter as volatile solids. So yeah, the dry matter, if you could refer that, if it would be, I can say it like this. If you refer to dry matter as TS, then add another 10% to the yields I predicted. So
Okay.
220 probably for
All
TS.
Right. Thank you very much. Thank you very much for that. I think we have time for another question as we're a little bit late. Maria, if that's all right for you. That there's another question about bedding in farming. That's an important one, I guess. There's a statement from Trevor that he states that herd homes are becoming more popular in New Zealand, and they are using composting barns or the type of bedding. There's another question about that in the chat. Is affecting also the opportunities for manure harvesting and biogas generation. So what's the it's more a statement, but well, how do we deal with different types of beddings and biogas? Torben.
I can say that I have also answered that in the chat. And if you look at my last Zenki diagram, which I don't went into detail because such a big topic, so little time, but you will see that I have not included the bedding in the TMR system into the AD. Why? Exactly because of this question. Because if the bedding is sand, I would hesitate to chuck it in the digester because first it settles down and you don't get it out as easy. Secondly, it also wear up the pump and the internal material. So yeah, don't do it. However, there is sand is really beneficial for bedding. We know that it's really good. However, if AD is used, there might be the potential to do a separation approach with the digestate to then use the solids as a bedding, the separated solids, because it's kind of the pathogens are significantly reduced. It's safe after AD process to use the separated solid as a bedding. And then if the cows leave their residues on the bedding, that can be fully chucked in the digester again. So that would be a potential solution to get around the sand bedding.
Okay, that's a very good answer. So thank you very much. Well, I think we're in the end of our webinar. There are many more questions open, and as Maria stated just before, we'll circulate all the questions among the speakers, and within our slides, you get all an answer to these questions you have risen. So at this point, I would like to thank all the speakers for their very insightful presentations. And of course, to everyone who joined us today, that was really great. I think it has been a fantastic session, and I hope you found the information useful and the discussions fruitful. There was not too much time for discussion. Probably we have to do that a little bit better next time to give you more space to ask questions to the experts. I found it very informative and inspiring. I hope you did the same. Before we close, one more remark. please find on this last slide I just shared the link to our website with all reports and informations. Most of your questions have been addressed in some kind in one of the reports. Feel free to search through our website and stay connected with us via LinkedIn. Then all the other upcoming webinars will be promoted there, and all the reports we do. And also you can reach us if you have specific questions that we can ask and discuss among the expert group we have. So it would be great if you follow us. Thank you again for being with us at this webinar. We look forward to engage with you in the future for more webinars, for more information. I'd like the speakers to stay a little bit when I end this session. Thank you very much for being with us. Have a great day, everybody, and goodbye.
Bye-bye. Thank you.
So I'll end the
Goodbye.
event.
Thank you for hosting. That was brilliant.
Just
Goodbye.
stay online for a second, all the speakers. I just try to end the event, and I hope you'll be still there. It should work like this normally.